Welcome, everybody, and we're live. It's a Saturday morning. Thanks for joining me, and we're here to talk about LEDs, but we're not going to just jump right in and start talking about micromoles and go crazy. A lot of people have asked me, hey, man, where can I go for some basics? So a lot of times as a YouTuber or content provider evolves and our knowledge level increases, we assume that our audience is following with us. But a lot of times we don't take the time to go back and take care of the people that are just joining the channel that subscribed yesterday or subscribed 2 months ago. So that's what this stream is about. If you're new to my channel, I'm Grow Mouse. Welcome to the channel. Thank you for your subscription and your support. And if you're not seeing this live, what I hope you'll do is when you're trimming or when you're in the grow room, you're under your HPS or your T5s or whatever, but you're at least interested in LEDs, you can have this stream going on in the background and just through osmosis, just pull in some very basic info and just give you a place to start, For example, I am interested in this guy doing these battery banks with these 18650 vaporizer batteries, and there's a guy doing power walls with these things, but like I'm new to his channel and I don't know where the hell to even begin. He's already doing the complicated stuff. So that's what this is. So I'd like to welcome my producer, Wookie Kush. Welcome, Wookie.
Thank you, sir. How's it going?
It's going great, man. How are things going on your channel?
Things are going good, man. Just making some corrections after somebody called me out on some shoddy installation, but we're rolling along, man.
I gave Wookie some criticism in the comments about his fan placement. I'm sure we talk about that a little bit later. I'd also like to welcome another YouTuber to the stream this morning, SoCal 619er. Did I catch a niner in there?
Yeah, I went back. I went to SoCal's Cannabis Garden because I moved and just kind of like restarting myself. So SoCal 619 or SoCal's Cannabis Garden, either one.
Very cool, very cool. And we'll go ahead and drop the links to these two guys' channels in the description of this video after we go live. So I'd like to invite you to go ahead and subscribe to their channel. And what we've got is we got Wookie Kush, who he's tried some of the China LEDs. We've discussed this on previous live streams, the blurple colored, eBay, Amazon LEDs, and the results were adequate, but he was looking for something more out of his lighting product. So he's recently gone with some chip-on boards that I helped him out with, right, Wookie?
Yeah, that's right.
Citizen. And it has the house caught on fire yet?
It has not. It has
okay,
not.
So we're in business.
Thank you, Grow Mouse.
So you can put this stuff together and not kill your entire family. And we're going to talk about some safety things here a little later. Now, SoCal's with us for a very different reason. SoCal, tell us a little bit about your grow setup for the folks out there that have not watched any of your videos.
Well, my grow setup is I'm running a somewhat sealed room. The only thing not sealed about it is my window AC unit. So it's like an 80% sealed room. So, I mean, there's no actual air intake coming in. I do run HPS. I have 2,000 watt HPS lights, and I do supplement with CO2. I use digital ballast, and try to use some of the top of the line ones, so that way I'm getting some of the better, some of the better spectrum. I don't know if it's spectrum. Maybe you can correct me there, but I know some of the older ballasts just weren't as efficient as some of the newer ones. And I mean, I've had side by sides where I've used some of the older ballast to some of the newer ones, and some of the the newer ones are definitely producing more and run cooler as well. So. But I'm definitely intrigued in this LED thing, but the one thing that's been kind of keeping me away from it is just not knowing anything about it. So, Mouse turned me onto some videos, and it's just really, really helped my, it's just, there's a point where, like, I kind of got an example the other day. If you walk into a house full of people who speak Spanish, you can't even talk to them, but if they were just to give you a few of the basic words to communicate, then you can actually communicate and then start to form more questions and start to get more, get a little bit more into it and figure out what you're doing.
Sure, that's a great analogy. What do you need to know? Food, water,
Hola.
hello. So,
Yeah, right.
3 words, and you can at
So,
least begin a dialogue. So that's what we're here to do. Unfortunately, we're not going to be bilingual. We're just going to be in English, but we're going to give you comida. We're going to give you casa. We're going to give you
right.
a couple things. So just touching back, you run a 2,000-watt HPS garden over what kind of square footage are we talking?
It's a 10 by 10.
A 10 by 10, so 100 square feet. Wow.
Yep.
Nice, easy math. So what we'll do is we'll go into SoCal's math, and we'll kind of see what kind of photon density he's getting today under 2,000 watts of HPS. And if he were to take that journey into LED, then we'll help instruct him on what to go with. Now, SoCal is here because he contacted me a week ago, right? Well, less than a week ago or something like that. And I'd already been familiar with him from being on the Trichome Chaser stream. Shout out to the Chasers. He reached out. He's like, where do I even begin, bro? Like, I mean, I'm an HPS grower. I have my methods. I've been doing this plenty long enough. Been on YouTube 4 years ago. But I just want to learn. I just want to kind of see what it's about. So I directed him over to my DIY LED series. And I think that it answered a lot of his questions, but we've got him here still so that he can act as our newbie. He's our SoCal. If you don't mind
the new guy,
you're the new guy. So what we're gonna
absolutely not.
We're gonna allow SoCal to kind of jump in and ask me the questions that a new person would want to know because he's a new person. Okay, so guys, what we're gonna do is we're gonna kick this off with briefly touching back on last week's live stream. Last week's live stream, I really hope to cover a little bit more ground, and I'll try to be a little more succinct, because when a grower is using one lighting product at a certain wattage, one of the most confusing things to him is, or her, is how many watts do I need if I go over into LED? I've heard what this website said and what that interview said. I need half the watts or whatever it is. So we're gonna show you the real live numbers. Now, everything here is going to be fairly simplified because we're talking to a brand new audience. And so I hope that the experts out there will allow me to kind of keep it simple and kind of keep it, in layman's terms. So we're going to cover SoCal's garden, and what we're actually going to do is figure out an estimate on how much light he has in terms of photons. So if you remember last week, we talked about the efficiency or the efficacy of any lighting product based on micromoles of photons per watt or micromoles per joule. And a joule or a watt is just a joule per second. It's the rate that we're paying. So a traditional single-ended HPS, SoCal?
Yes.
That's right. Okay. A traditional single-ended HPS with a new bulb and a good ballast is putting about something like 1.3 micromoles per joule. So what you do is you take the rate of the photons, the 1.3, I'll just do this live, 1.3 times the wattage that you're using. You're using 2,000 watts, you said. So multiply 1.3 times 2,000. And what that'll do is it'll give us the total amount of photons emitted from the light source, which happens to be 2,600. Pretty easy math. 2,600 then divided by your space in square meters. And for this given space, you're looking at 100 square feet, right?
Yes.
You have to do a quick conversion, which I was not prepared for. We're going to do a quick audible here.
Now I got a question though, Mouse. That's the full grow space, but that's not what I'm shooting for as far as the plants under. I'm shooting for about a 5x5 underneath the light. It's not like I have the whole. Does that matter?
Yeah, that matters actually a lot. So
Right.
The grow space underneath your 1,000 watts is a 5x5. So using
so you could probably about a 5x10 of actual plant underneath, of actual canopy.
Okay. I'll tell you what, let's take it back to a per light basis. SoCal is using a single-ended 1,000 watt HPS per 5x5, which I think is pretty standard. So we're going to take our 1.3 micromoles per joule. We're going to multiply that by 1,000 watts, which will give us a total amount of photons, okay, which is 1,300 micromoles per second of photons. And we're going to divide that by his space in square meters. A 5x5 happens to work out to 2.3 square meters. So when we divide that 1,300 by 2.32 square meters, you're coming out with an average kind of photon density of about 560 ppfd. So that might sound a little bit low to you guys, but that's kind of what you're getting, photon density. So it's 560 micromoles per second per meter squared. Now, if SoCal was to do something like use his SE HPS to do a 4x4, it's the same 1,300 total photons, but divided by only 1.49 meters. So that's going to give us more like 872. So that's kind of crazy, the intensity difference, you know, and the density difference. So if SoCal was using 1,000 per 4x4, he'd be at 872 ppfd, but he's going 5x5, so he's getting about 560 average. Now that's average. There's going to be hotter spots and there's going to be dimmer spots. And the reason we're going into this math is to give you guys a baseline of how much light you're actually getting for that 1,000 watts. Now, going into an LED product, the reason I brought this up is because you kind of need to know what the efficacy is of whatever the LED product you're using. Now, that's why I touched on it. That's why I went in such detail last week, and we're going to move past this soon. And I know this is sounding like it's getting more advanced, but I think it's important to take a moment, take a little time, and talk to these HPS growers so they understand how much actual photons they have in their space. So going into figuring out what you need, SoCal, do you have any motivation for going LED? Are you looking to save wattage? Like, why are you even interested in this?
Definitely to save wattage. That's the main thing. Yeah, I mean that's that, and just keep the heat down a little bit. I know that there's a little bit of a heat difference, right, between HPS and LED. Is that correct? I mean,
that's a great question. That's one of the most common questions. How much heat does one of these LEDs put off? How much savings are there? Now, there's two things that you have to realize, that we all have to realize, is that the laws of physics are called laws because you can't break them. If they were the theories of physics, they'd be open to being broken or adjusted, like in the movies. The laws of physics and laws of thermodynamics say, in so many words, that if you pull out X amount of watts from the wall, that's going to create X amount of BTUs in a sealed space. And what we've typically gone with in the past is something like 3,800 BTUs of cooling power per 1,000 watts. Now, there's a lot of variables like air cooling and insulated hoods and things like that. But LED is no different. If you're going to pull 1,000 watts of LED, you need to be prepared to have about 3,000 to 3,800 BTUs of cooling power. Now, here's where the savings come in, SoCal. You can do the job of a larger HPS for less watts, which means less wattage in, less BTUs that it needs to cool, right? So that's pretty obvious, right? The other reason is the quality of light. So there's a report online. It's, if you want to Google it or whatever, it's called the Cree Horticultural Reference Design, and it lays out all these numbers, all these metrics for 1,000 watt versus some LED. And one of the metrics they laid out there is that 15% of your energy that you're paying to light up your 1,000 watt HPS is coming out as infrared light. And while there may be benefits to infrared light, there probably are. Do we need 15.3% IR? Because I think we all know that IR kind of equals heat, right? I mean, in the garden, that wavelength of light kind of heats things up. That's why it shows up on a thermal cam like a FLIR or whatever. So we can reduce the wattage, the total input wattage, and do the same job for the plants while reducing the amount of IR we're putting into the garden, which further reduces it. So, you know, there's a reduction from the wattage and a reduction from the spectrum.
So you're actually paying for what you're using with LEDs, you know, for what you're actually using with the HPS. 15% of it you're kind of just throwing away from the IR.
I don't want to say that. Because I don't have the scientific data to back it up. So I kind of want to keep this with numbers from white papers and reports. And I'm not sure if it's tonight or not, but obviously you guys know Subcool. And I believe he's in chat right now, so I want to welcome Subcool to the chat.
Sub, what's up?
Sub is pulling some of the best people from around the industry. Jeremy from Build a Soil, Tyler from Horticultural, and perhaps those guys could go into the potential benefits of IR light tonight on their stream. So, you know, you might want to swing back and check out Subcool's tonight and get the other side of it. You know, get the Horticultural side of things and the benefits of IR. I personally haven't missed the infrared light. However, you know, one thing you'll notice across HPS gardens versus LED gardens in the same strain is that the LED colas don't look like as big, but they can oftentimes weigh out to be the same amount of flower material, or sometimes even more dense. So I believe that has mostly to do with the IR light, but a proper side-by-side hasn't been done. Okay, so we've got a baseline for how much light an HPS guy has. How much LED does he need? In my opinion, in so many words, about 600 watts of high quality LED is what you need to replace 1,000, 6 to 650, something in there. And when I say high quality LED, in the past, typically I've been talking about something called a Cob, or a chip onboard LED. And if you go to the industry shows, they'll say COB. I think the growers are the only people saying Cobs. This is a Cob, or a chip onboard LED, and these are two styles. This is a Citizen, this is what Wookiee uses, and this is a Cree, and this is what I have the most experience with, and this is what I have in my garden. And what a chip onboard is it's 100 or several hundred LEDs that are mounted to a tiny board that are actually blue in color. But when they put this phosphor layer, or this lens, it shifts the spectrum to a white, a warm, a neutral, a cool. So when you see Cob, all you new people, that's what a Cob is, a chip on board. Basically means 100 or a couple hundred LEDs, all on a chip with a single positive and a single negative. Now, when you see Cob Holder, and I'm trying to keep this kind of basic, but when you see Cob Holder, you're referring to a device that holds the LED on the heatsink. And the reason you need that is because it's such a big heatsink, a big LED, that you need to apply even pressure to the heatsink. And this is the heatsink. There's a couple types of heat sinks that we have to use to get the heat away from our LEDs. And we'll go into heat sinks and styles of heat sinks a little bit more. But I think what I'd like to do is officially announce the 2017 DIY LED basics. As I'm doing this video with you guys, I'm realizing that a standalone kind of produced series with all the new tech and everything is probably well overdue. A lot of people saw my DIY LED basics series from last year, but now it's been a year. And now we're starting to see these smaller SMD diodes or boards coming out, like the quantum boards. And I think we're going to see a lot more of these. What SMD means is surface mount diode. And then the final type of diode is what you'll see is called a mono. And what a lot of people refer to as a mono, it's a monochromatic LED. So a white LED is full spectrum, and a mono in shorthand for us means it's like a 660 nanometer red or a far red. So when you see mono, that's what that means. So today we're talking about Cobs. We're talking about printed circuit boards with SMDs on them, and we're talking about monochromatic LEDs. And we'll get into this a little bit later because this gets into like a little bit more advanced. So, SoCal, when you were starting, yeah, what's up?
I'm sorry to cut you off, man. How
no,
much
you
better
have
does
to,
the,
because
does the mic sound now?
I think I just did a 10 or 12 minute diatribe intro. What's up?
I said, how much better does the mic sound now?
It's a little better. It's a little bit less tinny. So I think you're on the right
Probably
track.
because I need to fucking plug the thing in. Oh my god.
I was lying.
You're hearing me off.
Are you talking out of your webcam right now? Is that what's going on?
Is this live? Is this live?
Yeah. Oh wait, hang on. Yeah. Okay. Watch this. Ready? Are you ready?
All right. I'm ready.
Give me a second.
Okay. Giving you a second. I'd like to also welcome
How do we sound now?
Go ahead.
Okay.
How we sound now?
How's that sound?
Really crunchy. You were better before.
I'm sorry, guys. I'm running this show. Hey, I'll figure
That's
it out.
okay. My producer is he's not fired, but we're definitely gonna have to get it. We have to go into HR. We have to write him up. You know, in case he claims sexual harassment.
I tried to do a good thing, and it's not working for me. I'll figure it out though.
Grab your old mic. In the meantime, so SoCal, when you were getting interested in this last week or the week before, you end up watching my series. What were kind of some of the things that were daunting to you about just getting into this?
Just mostly like the, you know, like how to figure out how to match up the drivers to the LEDs and like how to figure that out. And, you know, just like, are the LEDs, are you guys talking about, you know, are you guys multiplying or dividing that by the milliamps of the, is it milliamps, right?
Okay, yeah, no, that's a great question. That's a great question. So let's get into some practical applications of LEDs. So you're a guy named SoCal, and you've got a certain lighting setup over your garden and you're getting a certain garden performance, but you're interested in LEDs. You understand, or maybe you take my word for it, that if I'm telling you 650 watts worth of Cobs can do a job for 1,000, that's good enough for me. I don't need to see the math. We'll worry about that later. But now I'm ready to pull my credit card out, or what I should be doing is pulling a piece of paper and a pencil out and designing a light for my space. Okay, so you've got basically a 5x5. Same thing happened last week. Jeez Louise. Somebody remind me, the black one's out. The black one's toast. That's why we're going blue. Okay, so you got a 5x5 space. We'll go whiteboard here. 5x5 space with a 1,000-watt light. 1,000-watt. And the rate of photons that you're getting is 1.3 micromoles per joule. And we figured out that over that 5x5 space, you're something around, you're around 600 ppfd average over the canopy. That's how much light you have today. Now go into LED, how much light are you going to need? Well, if you work backwards from 600 ppfd, something like around, let's use the 650 watt as an example. So 650 watts of LED, or let's just say Cobs, okay? Now, that's why I keep harping on micromoles per joule, because that's the rate. That's the piece of data that you need. Oh, Jesus. This is just not, sorry. The micromoles per joule is the rate that you need to compare apples to apples. And that's why I'm harping on it. Not because they're, spectrum and stuff like that isn't important, but to compare apples to apples, you need to know the micromoles per joule. And that's why that's why a lot of people go into them, because it seems like a cheat. It seems like a hack. I could get more light per watt used. And so I've showed this before, but I have an integrating sphere report from a lab up in Washington State on the Cree CXB 3590. Now, this is a Cree CXB 3590. It's probably one of the most common chip-on boards around, and you'll see this on websites like Rapid LED, Cutter Electronics, Timber Growlights, very, very common Cob. And it's a 36-volt model. We'll talk about the math that you just alluded to in a second there, SoCal. But using the Cree CXB 3590, if you're running it at various drive currents, it has various levels of performance. So here's kind of how this works, okay? If you look at your wattage that your Cob is putting out on this axis here, this is your wattage. So 50 watt, 30 watts, 50 watts, 80 watts output or consumption on the Cob, the efficiency goes down. So the hotter you run a Cob, the higher you run a Cob towards 80 watts, the less micromoles per joule you get. So if you're running it up at 80, you're getting something like 1.7 micromoles per joule. And if you're running it down at 30 watts, you're getting something like 2.3 micromoles per joule. So why not run it at 30 watts? Well, that's when money starts to come into the equation. To run these Cobs very soft, you talked about milliamps, SoCal? Yeah. Milliamps, you understand, is the current or the strength that you're driving the Cobs, right? So
right.
The current determines the strength, determines the wattage. The voltage is constant. So if you're running down at 30 watts, you're getting a higher rate of photons, but it's more expensive to do it that way. If you're running at 80 watts, you need less Cobs, but the rate of photons they're putting out is less. So let's just for round numbers and ease, we're going to start talking about the 50 watt setting for 36 volt Cobs, which is about 1400 milliamps. Okay. And what that means is that the driver that you purchase puts out a constant current, and that constant current is denoted here. So this is an LED driver. This one happens to be a Meanwell. And if you look where my finger is, this one happens to be a 1050. There's 700s, there's 1400s, there's 2100s. This determines the strength and the wattage that you're running on the LEDs. Now, when you're matching Cobs to drivers, there's one very important piece of data that you need, and that is how much voltage is the driver putting out. And that's noted on the driver. It's probably gonna be too small a print to show here, but this driver happens to put out 238 volts, okay? So all you do is you take your 238 and you divide that by the voltage of your Cob. So if we're using 36 volt Cobs, this will run 6.6 Cobs. So 6 to, for practicality's sake. So that's how you match drivers to Cobs. The total voltage divided by the voltage of the cob gives you the number of cobs. So let me step back. I've gone a little too far. We still need to find out how much wattage you actually need to cover your space, equivalent to your 6,000 or your 1,000 watt HPS. So to do that, you basically just work backwards, right? You take the 600 ppfd, you multiply that by your area in square meters, and that gives you the total amount of photons. And then you divide that by your new metric, which, like I said, for 50 watt cobs is about 2.1 micromoles per joule, which works out to be about 650 watts. So 650 watts will give you the equivalent amount of ppfd as your 1,000 watt HPS, whether that's a 4x4 or a 5x5 or whatever. To get to 650 watts, how much money is it going to cost you? How many components do you need, right? That's probably your next step. Like, let's say you're getting ready to build one of these fixtures. Like, what do you even buy? Do you have any idea, SoCal, what you would do? What you would buy?
Not really, no. Not exactly, no. I mean, okay. I was just checking out some of your fixtures and your number 7 video on there, but I didn't really get to write down as much info I wanted to on there. So I was, fixtures is definitely something I'm not really, I have no idea about.
You kind of have to watch the videos twice. Like you absorb it once. And then
yeah. Okay, maybe even 3 times.
The reason I need to do the series is that back last year, the Cree CXB 3590 was like the leader of the pack. It was pretty much the only option for people that really wanted to see big gains from going from HPS to LED. Now we've got the Citizens. They're coming on hot and their numbers are great. And then we've got the Veros, which I don't have here. Now, if you can forgive me for the oversimplification, I want to answer the question, should I go Citizen? Should I go Vero? Should I go Cree? Should I go Quantum Boards? And I'm just going to lay out basically a rough guideline. If you have a big budget and you're living in Hawaii or you're living in Northern California where you're paying 40 cents per kilowatt hour and you can afford it, I still believe that the Cree CXB 3590 is probably going to be the best chip to run efficiently at a low current. It means you need a lot more of them, so it's more expensive. You're running them at 30 watts to 50 watts each. So you need more of them to get the wattage, right? You'd need 12 of these to get 600 watts. And you're going to get this CXB 3590 performs best when running soft. Now, when you increase the drive current to get more watts per chip, that's when things like the Citizen and the Vero Gen 7, Vero 29 Gen 7 start to pull ahead. When you start getting up to 2100 milliamps, which is like 72, 75 watts a cob, or you get up to 2.4 milliamps, you're getting more bang for the buck. It's a more economical build. That's when those Veros and those Citizens start to pull equal and even pull ahead of the Cree. So for super high-end, super efficient builds, stick with the Cree. For more economical bang for the buck builds, go with the Citizen or go with the Vero 29. Then we've got the Quanta board thrown in the mix. And there's 2 of these that I don't think we're going to be able to go into very much because I haven't worked out the metrics on, watts per dollar, but this is another viable strategy for people that are illuminating small spaces, illuminating vertically, challenged or vertically limited spaces, or just a general all around good choice. So I think we're going to veer clear of the Quantum board, but it is another viable option. I want to kind of keep this around Cobs. So when you're determining, how many Cobs you need to cover your space, I like to look at my space, whether it's a big square, like a 4x4 or a 5x5 or 3x3, and build the fixture accordingly. Or if it's a rectangle, spec and build it accordingly. So if you're running a 4x4 or 5x5, I feel like the best configuration is a block or a grid of 9 or 12 or 16, keeping it kind of linear, keeping it to where the spread is going to be nice and even over the square space. If you're running a big square space, you build a big square light. So for you, for 4x4 to 5x5, we know you're going to need 600 watts. If you're running each of the Cobs at 50 watts or 1400 milliamps, that puts you at a dozen Cobs, right? 12 times 50, 600. So if you're getting 12 CXB 3590s, 12 heat sinks, that will cover your space. That'll give you the same performance as a 1,000-watt HID. And then you have to match up your drivers, and there's a couple options. Now, we're going to go a little further into, more on drivers here in a second, but I just wanted to pause, see how Wookie's doing, making sure everything's okay on the producer end. You getting it, buddy?
I think I'm good now.
You're good
Am I
now.
good
You're
now?
perfect. You sound great.
Oh yeah.
You sound great.
Fantastic. Fantastic.
Okay, cool.
Just want to give a quick shout out to chat, man. We kind of been neglecting chat this morning. Got a lot of people hanging out. Subcool 420, Fada Mike, Woody, Isn't Her Grows hanging out. Alaska Med Grower, Dirtman Dan. Got a couple questions when you're ready for them, but I know we're flying down the track here.
Yeah, chat. I'm sorry. I love you guys, and I'm glad you're here. I wanted to kind of get as much information laid out in this first 20 or 30 minutes as possible for people that are watching it back. So, yeah. Okay, keep going, Wookie. Loyal to the soils in the house. Love that name, Dirtman Dan. Norwegian Frog, Free the Frog. High Roots in the house. So
love the Grow Shack too, man. He's all over.
Grow Shack. Yeah.
Got a question from Grow Shack. This kind of and I can tell you from personal experience. Obviously, you guys have seen my channel. We've talked about it on here, but I think when they see your videos and they hear the prices and they kind of calculate it out. They say, okay, this is what I need. Mouse is telling me here in this video. It breaks it down real simple. But wait, bro, there's a kind LED. Like these are cheaper. Are these just as good? And that's what he's asking in chat. He's saying, hey, Mars Hydros is all I can afford, and how are they?
That's one of my questions I have written down here.
Okay. No, that's
cool. Two birds with one stone.
That's a really great question. And Wookie, while I look this up real quick, what other kind of questions are we getting in chat? Because I feel like I have a tendency to take something simple and keep expanding on it. I really want to keep this simple and basic, and maybe what we do is we pull me back in. I'll answer more SoCal and more of the chat's questions about LEDs. Okay. So the first one is about Mars LEDs and cheap LEDs and stuff like that.
Yeah, he's asking about. He's saying Mars Hydro is all he can afford, and how are they? And I can tell you, I know Grow Shack. I follow him on Instagram, and I've seen some of his stuff. He's kind of a new grower, just been starting out. He's got a tent going, and he's got an HPS in there right now. And I think we could probably, as a panel here, kind of come together and tell him that he's probably a little better off with the HPS that he has now than going over to like a Mars Hydro. Wouldn't you say, Grow Mouse?
Yes, and I'm going to tell you why. I wasn't happy with the way my screen shares were going last week, so my hope is that this one is sharing a little bit larger, and I think I can maybe even bump this up a little bit so that people can actually see it. So I want to talk to all the people that are out there that are in chat right now that are talking about, maybe kind LEDs, black dog LEDs, Mars LEDs, and I'm not picking on anyone specifically. Because when you have scientific studies and published white paper studies, you don't really, you don't have to make apologies. That's just the data. So I want to talk about a little data. And what I'll do is right now I'll go ahead and link this this white paper study in chat. And it's probably one of the few white papers that I think people would be really interested in reading because it's about grow lights. And this is by Bruce Bugbee from Utah State University. He studies light and plant morphology, and he's published many times over, including being on a panel of published authors for NASA and lighting and how it pertains to plants and space travel, et cetera, et cetera. So this was published in 2014. So the data is a little bit old. Non-acrophobic growers saying change camera view. Oh, okay, I got it. Okay, so Bruce Bugbee, 2014, economic analysis of greenhouse lighting. And before you grab your pillow and take a nap, you might want to pay attention because this study has some charts that's talking about like popular lights that we use, like the sunlight supply and different LEDs and ceramic metal halide and all this stuff. And I want to draw your attention, and please excuse the quick scrolling, but I want to get down to the chart where he actually shows real products, and of course it's going to be in. Okay. I can't catch a break. Of course, he's going to have the freaking PDF. He's going to have the PDF sideways. So while I fix this sideways thing, I just want to talk about these different LEDs. So these cheaper LEDs, like, the Mars and there's the Black Dog here and stuff like this, you're not really getting many photons per watt. You're getting something like 0.9 and 0.96. You're getting less efficacy than you're getting with a standard HPS. A standard HPS, they've got around 1.3, 1.4 micromoles per joule. And I know, guys, I'm sorry this is sideways, but it just freaking is what it is.
Cool.
So you go through this chart and you can see some of these popular LEDs. They got the Lumigrow, they got the Apache, the Black Dog, the California Lightworks, Solar Storm. And granted, this was 2014, so the new models may vary, but the reason why you don't get any watt savings or any additional performance out of one of these cheaper Amazon or eBay, like Wookiee, like your LEDs that you bought, is because you're getting less light than an HPS per watt, right? So your lights were probably around 0.8 to 0.9 micromoles per joule. That's the rate, that's the photon yield. So I'm getting twice as many photons per watt out of my Cobs, or like you are now with your Citizens, than you were getting out of these blurple lights. And you can read more about that here, but I just wanted to show you guys, before I start spouting off numbers, some kind of scientific baseline for where these numbers are coming from. I'm not making them up. This is coming from white paper science from universities. So does that adequately answer the question? I mean, like if you're shopping for a Mars, what's the point?
Well, real quick too. I mean, and something I've heard recently from talking with some friends and stuff, and about this subject is, LED companies are good, bro. They're convincing with their with their sales pitch and their claim to proprietary technology and all this stuff. So people hear us talk about Mars LEDs, and we kind of use Mars as the general, is for all the blurples. But what is it about the technology specifically? Is it something about the 5 watt, 3 watt chips that are doing this, or is there these people out here claiming that their light is somehow better than Mars, or they have some type of new technology when they're really just rebranding the same stuff? I mean, is there anything there, or is it all just the same thing?
I'm going to speak very generally here, and I'm not going to throw any specific companies under the bus unless I've opened them up. So there's a chip out there on the market called the Epistar, or the heat sink slug LED. And this is what that looks like, okay? This is an Epistar diode, and there's also Bridgelux that makes Vero. They make a very similar diode that has the same footprint. And what this is called an active slug-based diode, okay? You guys that have had, Mars burn out and other Chinese LEDs burn out, you look at it and the lens is all foggy and stuff. That's this diode, okay? Now, it's not a rebranding thing. It's that these are extremely cheap. You can get these for sometimes less than 10 cents, 13 cents, 14 cents, 20 cents. So we're not talking about a $15 to $30 chip. We're talking about a 15-cent diode. And what these companies do, a lot of these companies do, is they take a mixture of these in different colors and they create their proprietary blend and their morphogenesis spectrum, and they market it to you in a way that's like, some nerd like me, like educatedly / arbitrarily picked out a selection of diodes, told this factory in China, they put a couple hundred of them on a board, slap a sticker on it, and there you go. You've got this LED, that LED. I mean, most of the cheaper LEDs that are under $200 have this Epistar. And these are the kind of things that are giving you 0.8 micromoles per joule, which is far less than an HPS, and basically half the output of a ceramic metal halide. That's why for the people that can't afford LEDs, I'm like backing ceramic metal halide, because you can get so much more light out of them per watt than you can in Epistar. So I know this is a webcam and this will be covered in my more produced series, but if you see diodes that look like this, run for the hills, because you're better with ceramic metal halide. And I can say that definitively with the scientific backing of the Bruce Bugbee study from Utah 2014. Now, that doesn't mean that all small diodes are bad. In fact, when you see the smaller surface mounts like a Cree, this package is so much more efficient and so much more effective at getting heat into the heatsink or into the star that you can actually get better performance than a ceramic metal halide with the right package, like a Cree or a Phillips or an Osm or something like that. So don't take it the wrong way. Small diodes aren't bad. It's just that this Epistar technology is so old. Like, I was still in college when it came out, and I'll be 40 in a couple years. So that's how old the freaking technology is. What else do we got question-wise?
All right, let's see here. Somebody's asking, this is from Boston, the Boston 317.
Okay.
For wiring, do they just need 18 gauge or does the voltage matter? When wiring Cobs to a single driver, does color spectrum matter or just the Cob type?
Well, the wiring question is a great one, and I get this all the time. I've used every kind of wire from Radio Shack, from Fry's, from AutoZone, and what I find that works the best is if you're on an extreme budget, you go down to Lowe's or Home Depot and you get 18 gauge solid core doorbell wire. If you can afford it, it's about twice as expensive, but the insulation's better. It's called Shaxon, SHAXON, and it's linked in the description of every one of my videos. It says best Cob wire because it truly is. To enter these Cob holders, you need a solid core wire. An 18 gauge has a 300 volt rating, which usually covers us for most applications. So what was the second part of the question?
Okay, I'm on. Second part of the question was, to a single driver, does the color spectrum matter or just the Cob type?
To a single
asking
driver.
is if he's putting different Cobs or diodes, together that have different spectrums, can they be wired into the same driver? Is what I think he's asking.
Oh yes, absolutely. What you're going to notice when you're looking at chip on board specifically is that you see how one of these is yellow and one of these is more orange. In a very basic way of explaining it, the higher Kelvin typically are more yellow in color, and the lower, like a 3000K, are kind of a more orangish color. And these two chips, if they're both 36 volts, the driver can't tell the difference. So you could have a 5K, a 4K, a 3K, and a 2700, and it's all the same. Yeah, you can mix them on the same driver. It doesn't affect the voltage or the current, typically. What else do we got?
Hey, Mouse, when you're messing with all that
Good
stuff,
question.
do you have to ground yourself out?
I have one of these little bracelets that I have, especially when it's dry outside, when it's 20% and you've got your fleece jacket on and you touch your dog and he's like, because you static shock him. That can ruin semiconductors. So having something to ground yourself is usually a pretty good idea. Another option would be like a grounding probe or a grounding mat that you can get off of Amazon for electronics, and you just, you touch the bracelet to that ground, and you can do that when you're working with this kind of stuff. But if you're touching the outside, usually you're good. But if you're in a dry climate, yeah, you might want to ground yourself. Hadn't burned one up yet, but yeah. Cool.
Okay, we got a Hijack 420 is asking if you can replace a CXB 3070 with a 3590 on a 4 Cob setup ran on a Meanwell HLG 185 1400.
Absolutely. Okay. What the notation for Cree means is that when you see CXA, that denotes like a 38 to 42 volt class. And when you see CXB, whether that's a CXB 2530, 3070, 3590, as long as it's got the B, that denotes it's a 36 volt. The driver's not going to really know the difference if it's a 3590 or 3070. And for the new people that are out there, when you see 3590, that refers to the geometry of the package. Okay, this is a 3590. Although this is technically a Citizen, this is the size of the 3070 package. So you see, it just refers to a bigger chip in the same family. But it's the same voltage, and the driver won't know the difference. So the answer is yes.
Here's another great question. Sid Avery is asking, what about the CRI? How much does that matter?
How much does CRI matter? Okay, so the sun is 100, should be put in fuse. Okay, I've got a great comment about parallel wiring and safety. We'll talk about wiring in a second. Shit, what was the question?
They're asking about CRI and how much does it matter?
CRI matters. There's definitely some debate about quantity of spectrum. and quality of spectrum. CRI is in the quality category. The sun is 100 CRI, color rendition index. Like, so when I look at a light source, an artificial light source, the higher the number, the more it appears like the natural sun to my human eye. So if you look at something like an HPS, it's like 22 CRI, which is pretty easy to believe, right, SoCal? Because the light is like orangish, yellow, something like that, right? And when you look at a standard chip on board white, you're getting like 80 CRI. Now, he's probably asking, should I prioritize going 90, 93, 97 CRI so that it's more like the sun? When you go higher in CRI with a chip on board LED, there has to be typically more of this phosphor coating, which is a lens that technically blocks light. Okay. So what you do is when you go higher CRI, you sacrifice total light output for quality of light output. And in my opinion, this is a philosophical thing. I would rather have more photons because photon quantity is what drives photosynthesis, and then concentrate on the quality of light. Now, I think, Tyler from Horticultural on Subcool Stream tonight, he's probably going to make the opposite argument. They're more a quality of light type of strategy, over at Horticultural, but I don't want to put words in the mouth. So in so many words, if you can get higher CRI, yes, it's good, but it's at a cost. And that cost is photosynthetic rate because of less photons. So, but that gets into a more complicated thing with like chloroplast saturation, all that good stuff. So, there we go. Yeah, keep going.
Okay, so we got a question coming in from Henkel89. Shout out, bro.
Shout out, Henkel.
He wants to know if you can give a quick overview about bins.
A quick overview about bins. Okay. Yeah, I most certainly can. And what I'll do is I'll pull up a little resource here. I feel like a lot of new people get very intimidated when it comes to data sheets because they just don't know how to even read them. So like SoCal, you made the analogy earlier about you walk in and knock on a Spanish person's door and, but like, how do you even find that Spanish person's house without a map, right?
A lot of us HPS guys have always done watts. You match the wattage of the ballast to the wattage of your bulb, and all that. So, learning what units of measurement you guys are actually using for the LEDs is one of the first things that I needed to know. You guys, you're going by volts, you're going by, milliamps, stuff like that. And that's one of the first things, in my opinion, that you need to know. You're not going by watts as much. You're using more volts and milliamps and stuff like that to figure out how many lights you're using and intensity and stuff like that.
Dude, I'm so glad you brought that up. And that's why SoCal's here, guys. And he's a cool guy. But he's here to bring that perspective because I forgot about that. I forgot about how daunting it was to figure out this LED stuff because my brain worked in watts for 15 years. Yeah. And now I got to come over here and talk about milliamps and voltages and shit. It's just too confusing. So, but that's just, unfortunately, there's no easy way around it. With LEDs,
well, just knowing it definitely helps out. Just knowing that, the units of measurement you're using helps out.
Oh, exactly. I mean, with the LEDs, it sucks because it's not like, oh, this is a 100-watt LED. It's not. It's capable of 100 watts, but it's variable down to 25 watts. You get more light out of it per watt at that rate, and it's like there's so many different variables. So going back to the question of bin, and thank you, Sid. I will remember about parallel versus series wiring, and I'll cover that before we answer any more questions. When it comes to bin, if you were to type in, CXB 3590, they're going to give you a data sheet. Now, I'll link that data sheet in the chat right now. That data sheet has the different colors. I think everyone's pretty comfortable with 6500K, 57, what all that means. But we're going to specifically talk about the 3500K because that, in my opinion, is a nice balanced spectrum for flowering growth. And you can even veg under it as well. Inside of that category, we just talked about CRI. There's the 80 CRI and then the 90. And what you'll notice by looking at the data sheet is that the 80 CRI puts out more light, puts out 12,000 lumens or 13,000 at a cooler temperature. If you just have to have 90 CRI, sure, you can get it. It's a beautiful color light bulb or LED. But look, you're taking 1,000 lumen loss. You're taking a 9% loss in lumens to get that 90 CRI. So that's the argument, quality versus quantity. Okay, so inside of these different CRI, we've got different bins, and bin or group is what is referred to here. So CB, CD, BB, BD. And when you're looking at the data sheet that I just linked, all you have to do is say, okay, what color do I want? I want 3500. I want the most output out of that LED possible, so I'm going 80 CRI. And inside of that 80 CRI, which output's the highest? So this CD denotes the highest output of 12,000 to 13,000 lumens. So CD is top bin. Alternatively, down here, you see BB is the lowest bin. You're pulling the same amount of watts, right? You're still pulling 50 watts or 100 watts, but you're getting less output per watt that you're paying for. So a top bin is a grade or a quality of LED, and it's very important. Okay, now I want to go into covering series versus parallel wiring very quickly because it was something that had been discussed in the past, but now that quantum boards are here, and it looks like they're going to be here to stay because I've been very happy with their performance, and I've only been running them for 2 weeks now in flowering, and I'm very happy with their performance. So, so I'll take this opportunity to make a quick note about drivers. Just a sec. Okay, so a newbie, a DIY LED newbie, has decided he or she wants to do a build, and they're in the process of selecting a driver. Okay, these are Meanwell drivers. They're the most common and highest quality drivers with the longest warranty. So you'll find these everywhere. HLG is the common series that we use. So, that's sort of a constant. 185 refers to an estimate on the wattage. So this 185 actually is capable of 200 watts, and this 240 is actually capable of 250 watts. It's just a shorthand nomenclature. So this refers to the wattage or the size of the ballast. This refers to the current, 700 milliamps or 0.7 amps. This one's 1050. And then here we have a B, and here we have an A. What that means is that the B has an external dimming lead that you can put to a cool knob so you can dim it. And the A version has the knob already right in underneath this cap. So you pull this cap off, you take a small screwdriver, and it's your dimming knob right there. So it's less, the A version is less wiring, it's less hassle, and you can still dim it. But the downside is if you ever plan on using a controller or something like that, there are no external leads to hook up to. Now, when it comes to wiring series versus parallel, these are your DC output leads. They're going to be red and black on any driver. Red for positive, black for negative. Now, traditionally, a chip on board LED type of setup, they all have a positive and a negative. So with the chip on board setups, you're typically talking about a constant current driver. What that means is that regardless of how many Cobs you have within the range of the driver, it's going to keep the current or the power constant across all of the Cobs. So you've had 1, 2, 3, 4, 5 Cobs. They're all seeing the same amount of juice, the same amount of brightness, which is important, for a grow room or a hotel. But with a constant current Cob driver type of setup, you use something called series wiring. And series is one of the easier sort of wiring types to talk about. So here we have a positive on our Cob. Sorry, live guys, we're live. We have a positive and a negative on our Cob. Okay. And we have a second Cob that's positive, negative, whatever. Okay. And what series wiring is you take the negative from the first Cob and you hook it to the positive of the second Cob. You take the negative of the second Cob and positive to the third. So you're alternating positive and negative. It's like when you put the batteries in the remote control. You know how batteries have that little nub on the top of a AA and the bottom's flat? It's like putting them in a straight line, positive, negative, positive, negative. What parallel wiring is I'm just going to use the same color for ease of use here. What parallel wiring is daisy chaining, basically, right? You've got 3 Cobs or 3 quantum boards. All the positives connect and all the negatives connect. And the difference here is in series wiring, if you have 1400 milliamps, that is constant throughout all of the entire series string. But what isn't constant is the voltage. So if you have 144 volts, right, and each cob uses 36, it's 144 is a bank of volts. It gets used up. So 144 minus 36 is 108, minus 36 is 72, minus 36 is 36, and minus 36 equals 0. So in series, your voltage is divided by the number of cobs. Parallel is completely different. It's the exact opposite. If you have 144 volts coming in on parallel wiring configuration, every single positive negative sees this 144 volts, but the current is divided, right? So if you have, let's say you have 2100 milliamps of current, that is now divided. So if you have 3 different boards, like quanta boards or whatever, each board sees 700, 700, 700, and 700 equals 2100, right? So it divides the current. So in short, series divides the voltage, parallel divides the current. And that's a pretty basic principle in electronics that's consistent throughout, all electronics. And the reason why this is important, and the reason why I wanted to spend a quick couple minutes on that, is because with quantum boards, they can be run in series or parallel very easily from the constant current drivers that we use. And I'll explore more about parallel wiring, about putting in thermal fuses, fuses in general, basic safety features, and the pitfalls for parallel wiring when we go into the boards, which should be in stock next week. So we'll talk about that more. All right, what else we got? SoCal, any questions come up during that little monologue?
Just that real quick. So that series of the parallel and those two ones that you just now showed, using the same 144 volt driver, if you run it in series as was the other one parallel? Was that what it was?
Yep, series versus parallel.
Would one be stronger than the other as far as light intensity? Because since you're breaking up the milliamps over the different amount of cobs instead of the volts.
I'm gonna do like your teacher used to do, and you're gonna hate it. Okay.
No, I'll probably love it if I understand it.
Okay, so what is current, and how does current relate to LEDs? SoCal.
The current is the milliamps, right?
That's right. Yep, that's the units of it. 1,000 milliamps equals 1 amp.
Right, and it relates to the intensity of the light.
Exactly, or the strength, like how much juice, how hard are you driving it? Okay, great, good. So we got that. And the voltage, how does the voltage relate?
I believe the voltage is the amount of current that the driver is capable of.
Current and voltage are two different things. So, they are two very important factors, but you nailed it on the current. The voltage is the bank. It's the amount of units available to distribute to the LEDs, right? So LEDs use volts, and then the current is the strength that they use those volts, in so many words.
Which is the milliamps, right?
Which is the milliamps. So when your driver says, I've got 144 volts to give you, LEDs, how many volts do you want from me? Oh, you want 36? Okay, we can run you. You want 36 too? Okay, we can run you. You two and you two want 36? Okay, that's 144. That's all I have to give out. I can't run a fifth.
So it's like if you're taking 44 shots, but are you drinking 151, or are you drinking shots of beer?
Well, that's a good point, right? In alcohol, you only have so many milliliters in a bottle of alcohol, right? So that's the quantity, and then the 151 is the highest strength. 151 would be like 2,800 milliamps. So when it comes to series versus parallel, with parallel, the voltage is going to remain constant. And like with quantum boards, for example, let's say a quantum board maxes out like this. This is one of the new 288 quantum boards. It can actually take up to 3 amps. So let's say we were running it on 144 volt driver at 2,100 milliamps. It can run one board at a very high strength, right? So you're pushing this board like crazy. Or you can run another board in parallel and it splits the load, right? All of a sudden, this board isn't being pushed to the max because its homeboy is over here saying, hey, man, I'll take half that juice from you in terms of current. And then a third guy joins the mix. And then it's like, okay, hey, guys, I'm in the party. I'll take 1/3 of that power, right? And keep going on and on. That's the beauty of parallel wiring, is the more you add, the more you expand, the less juice each board has to handle in terms of current. And the more efficient the whole build gets, the more boards you add and the more money you want to invest in it. With series, it's a little bit different. It's more of a set it up once and that's your setup kind of configuration. Does that adequately answer what you're talking about, series versus parallel, or do you
Yeah, absolutely. No, that totally does.
Don't be afraid if it doesn't, because I guarantee you there's 20 other people that are watching this that.
It's kind of like the difference. I mean, you can correct me if I'm wrong, but like using a 1,000 watt light or taking two 600s and kind of, I'm talking about HPS,
Yes.
and then taking like two 600s and maybe kind of it's lower wattage, but you're kind of spreading it out more.
Exactly. Or like if you're running 2,000s over your space and you switch that to three 600s, the wattage is kind of similar. The light output's kind of similar.
Which will cover more space, right?
Cover more space. Exactly. Okay, cool. Can I diagram Shredder 0911s? Can you diagram LEDs in parallel? Yeah. It's a little bit of a challenge, doing certain things on a live stream. Obviously I've got my board and I'm trying to do my thing. I'll definitely go more into parallel wiring, like in uber detail when we cover the quantum boards. I think I can get the video out next week, depending on if the boards I'll drop it even if the boards are not quite in stock. So I'll go way more into parallel because I know a lot of people are going to be trying these quantum builds. So Wookie, how are we doing, sir?
That's another quick
We're doing well.
question. Okay, go. Sorry about it.
Go ahead, SoCal.
As far as like the Cobs versus the quantum boards, I was talking to Photon a little bit, and he was talking about the thinness of the quantum boards help dissipate heat a lot better.
Sure, absolutely, absolutely.
Compared to like a Cob.
Imagine a Bic lighter, right? When you light a Bic lighter, you can light your joint because all of that heat is in one little area, right? And it's really hot. You can light a joint with it. That's kind of what a Cob is. All that 100 watts of heat is right in this small 50 millimeter, 2-inch little thingy. So that's why you need a big heat sink, like a pin heat sink or something that's got a lot of thermal mass behind it. You put the Cob on there and the hot spot's right in the center. And if you look at it under an infrared camera, you'll see that it's like a hot spot. And then the aluminum or copper, spreads out that heat, getting it away from the board. So you typically need a bigger heat sink to help pull that heat away from the LED so you don't damage it. With a quantum board, it might be the exact same 100 watts, but instead of a 4 square inches, we're talking about more like 72 square inches, right? So we're talking about 20 times more surface area to get rid of the heat. So the heat is now already spread across the board. It's back with aluminum. So you can actually use a smaller, thinner, lighter, cheaper, in some instances, cheaper heat sink to get the heat away, which does two things. It saves you a little weight on the build. It saves you a little money on the heat sinks. And it runs each individual LED at a lower temperature. I think that, there's one of the most important relationships in LED and DIY LED is the relationship between temperature and the LED itself in terms of how much output. And I'll cover that because that gets into a little more advanced topic. But in so many words, the cooler you can run an LED, the more light you'll get per watt. And that's denoted on the spreadsheets as well. In fact, it's somewhere in the order of 11 to 12% more light per watt if you're running it at like room temperature versus running it at like something like 85 centigrade. So good questions. Good question. Wookie.
All right. Captain Kindbud wants to know what are the benefits of the longevity of LEDs and how that is one of the best benefits. I'm not really sure what he meant there, but are there benefits to the longevity of LEDs?
Okay, that's a double-edged sword, and that's a two-part question. But one of the greatest benefits, Captain Kindbud, to LEDs is that you don't have to change them out every 6 months, every year, every 2 years, every 3, every 5 years, okay? When you're running your lights for flower on a 12-12 lighting schedule, you can expect 90% of the original light from day one at year 8. So you build a grow light, it's putting out 100%. 8 years later, it's still putting out 90% of that initial wattage, which is amazing. But the downside is the technology is still evolving so quickly that by 3 or 4 years from now, and for damn sure 8 years from now, you're going to want the new tech, man. So you end up taking these cobs and putting them in the parts bin or turning them to a shop light. But there's another strategy. Let's say Captain Kindblood buys the top end, best technology today, okay? And he puts 4 of them on a bar for his grow light, and he's running them at 2 amps, okay? Then technology changes 3 or 4 years down the road. He's like, man, my chips, dude, like I can get 20% more efficiency if I buy the new chips, but that's going to cost me money. And what do I do with these old things? One strategy you can use is take that 4 cob build at 2 amps, buy 4 more cobs, and split the current to 8 cobs instead of 4, right? So it's a 4 cob series configuration, a second 4 cob series configuration, and you just split the driver, daisy chain it in parallel, which splits the power, right, SoCal? So now it's 8 dudes doing the job of 4, which increases your efficiency up to that newer level, that new evolution. So there's definitely trade-offs. Just getting a monkey. Loki, I don't know what that means. Loki sent me an emoji with a little monkey going, so I don't know if that means, I don't know what that means. But Loki, if you're welcome to join the channel. Yeah. And then Green Jeans is in chat too, but he's hungover. So I think a micromole would maybe make his brain explode. Micromole pretty big number.
Green Jeans made a good point. The old Cobs make great shop lights.
The old Cobs make great shop lights. You heard it from Green Jean here, guys. Okay, what else? You got anything else coming in chat? I'm seeing a lot of red on my, when I say something and I see a lot of red, I don't know if people like it or hate it. So I got to scroll back and read. 70s Mama has got to run, but thanks for stopping in, 70s Mama. We really do appreciate your support. We got anything else? Engineer Khan Academy has some very good video on Ohm's Law series parallel. Okay, so Engineer is recommending Khan. That's KHAN Academy. There's a lot of great, SoCal. I really wish I would have. I mean, now that you're with LED and you understand, it's always easier to understand terminology under the context of something you're interested in. So you're interested in grow lights and weed and fucking growing herb, right? So now that pertains to grow lights, you can understand ohms and watts and all that bullshit. So Khan Academy and also Afro Tech Mods here on YouTube has some amazing, slightly more advanced on just general electronics. So thank you.
I used to do a lot of electronics for auto shop too. I took 2 years auto shop, a lot of multimeter readings and stuff like that. So it kind of, resistance, voltage drop tests and all that kind of stuff. So it's a little bit easier to understand when you've messed with a little bit of electrical before.
Yeah. Oh, absolutely. Absolutely, dude.
So I have a question, Grow Mouse.
Sure.
From this one kind of pertains to me. We talk a lot about, building lights for flower rooms and getting the most out of them and, what's going to give us the best production. But what about, building an LED for a veg room? I mean, what kind of, obviously we're not going to need to push them quite as hard. How do we design something like that?
How do we design it for a veg room?
Yeah,
okay.
For veg.
Okay, yeah. So for veg, we want to talk about quality and quantity of light, and there's going to be some difference in philosophy here. And you're going to find grower A, like a grower like Green Jean, and Green Jean's growing style. I'm putting words in his mouth here because he doesn't show his nursery and kind of where he keeps his clones very often. So what you generally see is you see a flowering room that's empty, and he'll put some, he'll have some plants vegged up to a certain size, and he'll put them under his main lights, whether they're dim slightly or not. And he gives his veg a lot of light. He wants to grow big, beefy stalks and stuff like that. You look at a perpetual grower like me, I have 4 trays, so I'm not full empty. I'm kind of, cycling in quads like Subcool would do. So for me, I prefer, in terms of quantity of light, I like to hit around 400 or 500 ppfd which is about half the strength of flowering. So if you're using 600 watts over a 4x4 in flowering, that's 300 watts over a 4x4 in veg. So I just basically use about half the wattage. That's the quantity of light. For quality, you can use 3500 Kelvin. It does great for full spectrum all the way through. 3500, you can use 4, you can use 5. For me, and the strains that I'm growing, I like a 50-50 mixture of 4K and 5K. I've done all 5K, and I've gotten great results from it. Very nice, tight internodal stacking. But because of the way I run my operation and the way I'm perpetual, I actually want a little bit more internodal growth so that I can take clones more frequently, right? When you're stacking real tight and you got to take clones every week, sometimes that takes you to 10 days to get a big enough clone. I find that mixing in the 4,000 with the 5,000 gives me a little more stretch in veg, just a little, and it works better for me. So in a very general sense, roughly 50 to 60% of what you would use in flower, and then somewhere between a 3,500 and a 5,000. I personally like 4,500 Kelvin or neutral white for my veg. You think is that good enough to answer the question?
Yeah,
I'd rather cover
exactly
more ground than get into any more micromoles.
Okay, so his and hers is asking, they say they want to remove their T5 and veg and put in LEDs. What's the best cost for the same production, and how much electricity would they save?
It's a great question. I have a video on my channel here, and the video is, this is where Malik, Subcool was like, you need mods, bro. I'm like, Subcool, you're fucking spoiled. that's why. We gotta, some mornings we got to do all this shit ourselves. So what I'm going to do as I attempt to multitask here is I'm going to attempt to link one of my videos where I directly compare a dual bulb 48-inch T5. And I think everybody's pretty familiar with the fact that a 4-foot T5 uses 54 watts roughly, right? So let me just go ahead and link this video so everyone knows what I'm talking about, and feel free to bookmark this for later. In this video linked in chat right now, I show how a 48-watt LED, 3-year-old diode, so not even the cutting edge 2017 tech. We're talking a 3-year-old diode, 48 watts of it can equal 108 watts of T5 in every possible dimension, and save you a shitload of juice and a shitload of heat. So what I discuss here is a $99 kit from Rapid LED. If you use the code GrowMouse at checkout, you can save 5% site wide, and that is a shameless plug. You know, gotta keep the lights on. But $100 basically in LED can replace 2 T5 4-foots, and that's in kit format. Kits are always more expensive because you have a set LED, a set heatsink, and a set driver. You can actually, and I'd be happy to work with his and her on this, obviously because they're friends and they're on the GrowTube round table. But you can take this like Dirtman Dan did, and you can adapt it, right? Now you can get a driver that can run 4 of these 50-watt kits, and you can save money. So it's like, it's not 100, 100, 100, 100. It's like when you start learning how to match Cobs to drivers and stuff like that, you could do $400 worth for like $250. Like as you build more, you get there. So if they're doing 8 T5 array, okay, so I'm going to stop. I'm going to pause because this is where I do the silver bullet part. The 8 T5 arrays are the most common. You take 8 times 54 and you get 432 watts. You can do the job of an 8-bulb T5 array for about 200 watts of 3-year-old technology like the Cree XML2. And that price point is going to be very similar after the first year of T5 bulb replacement costs. If you want to get into the newer technology like a Cree XPG3, that's got a little bit more photon per watt, you could probably shave that down to 180 watts, doing the job of 432 watts. And you can get even a better spread than you can with the T5s. But with that said, I'm not dogging on T5s. T5s are an excellent light source at providing a large diffuse area where you can get the T5s right down on the canopy, and that's why a lot of people like to use them. And in a future video this week when I update my garden, I will show you how 192 watts of 3-year-old technology is doing the job of a 10 bulb T5 in my little nursery. I'll show you guys that. So check
I'm
back on my
interested in that big time.
Okay, then I'll
I'm
definitely
looking to get rid of this T5.
T5s. Okay, I know a lot of
It's a
people
lot
love
of heat.
T5s. I love T5s. They're inexpensive. They're easy to get on Craigslist. The hydro store usually has them used. The bulbs aren't terribly expensive, and they're nice and diffuse. They grow great seeds. They grow great clones, etc. Okay, but they put out a lot of heat. They don't penetrate very much because the bulb, if you can imagine, the bulb is round. It's emitting light here. It's emitting light here. It's emitting light 360 degrees around, right? And there's a reflector. Anytime a photon bounces off of something, it loses energy. So when a photon hits a surface that it bounces off of, it loses a small amount of energy, and that energy becomes heat, and then it bounces off, right? So that's why your T5 reflectors are always very, very warm. And so 50% of your light coming out of your T5 is going somewhere. The other 50% has to hit a reflector at minimum once, but sometimes 4 times to get out of the reflector. And every time it hits that reflector, you lose energy. So with a T5 bulb, if you're running 54 watts, only 25 of those watts is actually getting there. The other 25 has to bounce around. So you're kind of like a governor on a car on the throttle. You're governed from the second you plug in a T5. Additionally, they're about 100 lumens per watt. Okay. And we're getting easily 130, 140 lumens per watt out of any decent diode that we're losing. So 50% more light out of an LED because it's going straight down, and then 50% more efficacy. It's just a no-brainer, you know? So I'm not trying to like shit all over your setup there, SoCal, or anyone using T5, but
No, that's good stuff, man. Because I mean, my T5 is it just heats up so much. It's ridiculous. It gets really, really hot. And like you said, the penetration. I mean, look at the top of the plants. You see really good growth, but the bottom does suffer a little bit. So, you know, that penetration is probably just not getting down there.
yeah, absolutely. Oh, look who decided to show up. Malik's here. No, hey Malik, thanks for stopping in, buddy. And to everybody, I knew I would probably stream, but I needed to leave myself an out. But imagine that I woke up in the mood to stream. So we've been going for about an hour and 22 minutes. So I just want to give a warning that we're not going to exceed 2 hours here. So we'll probably go about another 20 minutes on this stream, and we'll definitely answer newbie type of questions if anybody's got one.
I think I got a couple in the pipe here for you. So Sid Avery was asking earlier, and I don't even know what this means, but he's asking PWM versus analog dimming capabilities.
Good one. Okay. PWM versus analog. Okay. So one of the most common questions is, hey, Growmouse, I watched your videos. Thank you so much. You're a fucking inspiration, man. I'm going to smoke a joint with you at the cup. That's their words, not mine. But thank you. You guys inspire me too. I just built a cob build with 4 white cobs. And I understand that white light is pretty full spectrum. Full spectrum just means like, I'm not going down this rabbit hole. If you got white light, if you've got white light, man, you've got full spectrum. Okay. If you've got a light that has this many blues and this many greens and this many reds and this many, you don't even have full spectrum. You have multi-spectrum, because there's going to be these little slivers in between the range that those diodes cover. So that's one of the things that annoys me most of all. Why don't you use full spectrum? I'm like, I'm using full spectrum. You're not using full spectrum. You're using multi-spectrum, and you have little slivers that aren't available. But people ask all the time, I got a 4 cob white build. I want to go fuller spectrum. I want to add some monochromatic LEDs. How do I control those? How do I add those? So I'm expanding on this question in a little bit more detail for a good reason. A lot of people want to know how to add monochromatic LEDs and how to control them. Now, probably one of the simplest ways to add monochromatic LEDs is I showed you guys the Meanwell HLG drivers. These run your Cobs, okay? These take a 0 to 10 volt signal. Now, You can control that with a dimmer, and I'll talk about that in just a second. If you're wanting to do monochromatic LEDs, this driver is a great one that's very cheap. This is about a $7 to $9 driver. It's called the Meanwell APC 35. That means 35 watts. APC, as in cat, means constant current. And 700 at the end, that's the drive current. So you put your electrical cord here, or you can tie that in with your driver, and you get a certain amount of volts, a DC here, and you can attach that to a number of different monos. How many monos can you run? Well, let's look at the front. This thing has 50 volts, okay? These are 2.5 volt monos. So that means you can run 20 of these off of one of these, but this is not controllable. If you want to go into a controllable mono setup, and the reason I'm bringing this up is you're not going to buy a controller for just one white Cob driver. If you want to go with a monochromatic LED setup that is controllable, you'll want to get something called a DC power supply. This takes AC electricity and converts it to DC so that you can run your LEDs. So this is an LRS series. It's probably the least efficient, like 80 some odd, 85, 86% efficient at converting AC to DC electric. You can use the LEP series, Lima, Epsilon, Peru, LEP, and that's going to be a more efficient version of providing DC. Once you've got your DC electricity, then you use something called a bucking driver. This is another Meanwell product. It's called the Meanwell LDD, Lima Dog Dog. This is the LDD 700. And the LDD 700 provides you with 700 milliamps of current or strength, the same as this driver does, but it takes two steps. This goes from AC to DC, constant current on its own for $9. The alternative setup goes into a $40 power supply into this, but the benefit is this is controllable. Now, this only accepts a getting to the actual question, this only accepts a PWM or pulse width modulation dimming signal, okay? And it's 0 to 5 volt. And those are the two most common. In fact, those are the only two I know about. Inside of this series, you have a surface mount, you have a pin header mount LDD, and then you also have a wired mount that already has the wire leads on it. And this is the LDD-W. If there's a W at the end, W stands for wire. This is probably the easiest one to use if you're using a single. And it has dimming leads on it. There's a couple different strategies for dimming LEDs. For all your HLGs, for all your Cob drivers, you need what's called 1 to 10 volt. 1 to 10 volt dimming. And all of the Meanwell drivers have three types of dimming. They have voltage dimming, which means you supply a DC voltage in, and that determines the amount of current or strength that goes out to the LEDs. You have resistance dimming, which is when you put a potentiometer like knob on it. And then they have something called PWM, which stands for pulse width modulation. And all that is a dimming signal that modulates like this, okay? And so like this, basically all these troughs, it's off. So it technically is kind of like pulsing the LED at a certain rate, but the rate is so fast that the light just looks like it's on, right? But when you have your camera, it actually shows you, you can actually see PWM. So what are the advantages? PWM allows you to dim much more smoothly. So like a lot of times when you're doing voltage dimming or something else, you see it's a very jarring dimming. So as you go from 100% down, it's like these jerky points. PWM is a nice smooth dimming type of technique. Now, 0 to 5 volt is for like the LDDs for the monos. So you need a controller that's capable of doing 0 to 5 PWM and 1 to 10 volt if you're doing a mono setup on your Cobs. And there's a couple controllers that can do this. The most expensive is the Bluefish wireless controller. It's $200. The other one is the Hurricane by Steve's LED. And that one you have to select whether you want a 1 to 10 volt or 0 to 5. And the final one is the Storm X, or there's the Storm and the Storm X. One is a 6-channel, one's a 16-channel. The Storm X is a 16-channel. So in my builds, I've used the normal Storm, and it needs an adapter to take it from 0 to 5 volt to 0 to 10, but it does both. So the cheapest way to do PWM dimming is with the Storm controller and the 1 to 10 volt accessory. That way you can do both the LDDs and the HLGs at the same time. Okay. Anthony Wright is asking, please tell me this video won't be removed for watch later. No, we'll leave it up, man. We'll leave it up. That's why I'm going into such detail on a lot of this stuff, because it'll stimulate further questions, which will stimulate further ideas for more detailed videos. I don't think I've done a very good job covering controllers at all on this channel. And so that's definitely something I want to prioritize talking about a little bit more. Cool. What else is going on? What else is happening in chat?
I got a quick question. It's kind of off to the side for you. It's not really pertaining to, do-yourself builds and stuff, but as far as like LED lighting goes compared to HPS, like wearing Method 7 glasses, how is it on your eyes? Is LEDs better on your eyes, or?
LEDs
I know
are
HPS
not better at your eyes.
They're not going to?
No. What were you saying? LED or HPS screws with your what?
Yeah, HPS lighting can really mess up your eyes after a while if you don't use proper like eye protection and stuff. Is the intensity of LEDs like similar, the same type of thing, or?
Yeah, it is.
Yeah.
And in fact, if you do the math down to either photon or luminous output per square millimeter, the LEDs oftentimes can have a more intense beam of light going into your retinas, into the cones and rods in the back of your eye, and LEDs can really damage your eyes. In fact, I think that having some kind of glasses or some kind of optical reflector, whether that's a reflector like this or an optic that's frosted like this one here that beams the light. So that way when you walk up to your LED, the beam is going straight down. And if you're, at eye level, none of that incident light is directly touching your eye. This is safety measure number 1. Safety measure 2 would definitely be like Method 7 or Wavelength is another brand of, I believe their price point is slightly more aggressive than Method 7 due to them trying to make a name for themselves. So check out Wavelength sunglasses and Method 7 on Instagram. And yeah, definitely not a bad idea, man. I wear sunglasses. I wear cheap giveaway sunglasses when I do my builds. You'll oftentimes in my build videos, you'll see a pair of sunglasses there. Very important. Great question. Safety that's another video. I haven't done anything on safety, and it definitely needs to be explored.
On our Trichome Chaser stream tonight at 8, I'll be giving away a pair of LED glasses that I picked up from the hydro store the other day.
Oh, really? Okay, cool,
Yeah.
cool. Let me pimp. Let's take a second to pimp that. So that
It'll be at 10 o'clock to give away.
Okay. I'm just gonna screen share because we definitely want to show the love to our fellow streamers that are revolutionizing the YouTube game. So SoCal, give us a pimp out Trichome Chasers. What is Trichome Chasers? What do you guys do?
I think Wookie could probably really, talk about that a little more. He's been there longer than me, but I've only been there for a few shows. But we're just a group of guys. We don't like to, structure everything too much. We'd like to kind of keep it like more of like a hangout style stream. So, there's a lot of people from the chat stuff that we bring on and talk to them and stuff. And we're getting a little more structured, I guess, as far as topics go and stuff like that. Try to get it to where, people can look up our videos and see our title and just be able to tell what we talked about during those streams, so just a group of guys that like to hang out.
Very cool.
So Trichome Chasers TV for everybody that's not subbed up to it though, just so you know, it'll be, our plans are for it to be, a one-stop shop. So kind of like a, like your CNN or your Fox, or it's more of a TV station than it is one in particular stream. So you got streams on Monday, you have streams on Tuesday, Wednesday, every day of the week, different times of the day. That's the eventual goal. Right now we have Saturday as our main stream, 8 p.m. Pacific. We have streams on Tuesday, specifically relating to cannabis seeds. We have a couple other streams sprinkled throughout the time, but just so you know, it's not really one specific time or anything, but it's kind of building, and it's going to be a one-stop shop. eventually.
Awesome, man. You're covering genetics. You're covering organic practices. I wouldn't mind seeing a little bit more bottle talk. I don't think that'd be very popular amongst your cohorts, but seems
No,
it seems a
no,
little
it's coming. Yeah,
silly
it's
at times.
you
Or
know,
am I?
and actually the organics is going to be starting on Wednesdays now. So there's going to be kind of all the no-till vibes are going to be funneled into Wednesdays. So it'll kind of keep it off the Saturday stream, how it's kind of been. Gotten a little
That's
some complaints
cool.
about that.
And what else is cool is, obviously the roundtable does Friday nights. You guys had been doing Saturday nights for a very long time. And then Subcool kind of hopped in the mix, and Saturday night was a good night for him. And it looks like Subcool's kind of adjusted his stream time. He's going on at 6, like 2 hours before you guys. So
Appreciate that.
That's kind of cool, that everybody's, we're trying to work with each other.
Absolutely.
Hey, it's going to get to the point where there's going to be 3, 4, 5 streams on at once. But in the early days, we're all trying to work together and spread the love. So that's pretty cool. So if you want to stream binge, Subcool at 6, Trichome Chasers at 8. Who knows what's happening late night? Grandmaster level might fire up like a 2 a.m. fucking stream. Who knows? But so hey,
I think it's great though. I think it's great for the viewers, man. I mean, you got options. You know what I'm saying? Like you said last week. Say you pop over to the Trichome Chasers and they start going off on organics again. You're like, fuck this. Go check out Sub. You're on Sub's channel. He's talking about something you don't want to hear. You go back to the Trichome. I mean, it's multiple things going on. It's just like when you're watching your TV, right? You flip it through the channels. I love it.
Sure. But when Game of Thrones is on, don't you dare try to call me.
Well, cool. Shark Tank for me.
Hey, I want to welcome Saf de la Jungla, Saf of the Jungle, to chat. He's an ocean grown overseas guy. So shout out, brother. Thanks for stopping in and showing the love. Follow him on Instagram, Saf de la Jungla. God, wouldn't it have been great to have gone to Spanibus, man? I mean, everybody that came back was just like, bro, I'd love to use words, but your tiny, feeble little brain can't understand how dope it was. We got Urban Farmer, Woody. Special shout out to Woody. He's around supporting a lot of streams. So is Stink Bomb Inc., Jamonius, Urban Farmer, Denugs, Grow Lab is out there, Soil Biota. He must have been off last week. I notice when people take a week off, Soil Biota. What the hell? Where you been, bro? Grownonymous.
I saw Soil Biota last week.
Oh, you did? Okay. Well, maybe.
I think so.
Maybe. Okay. Boston Deadhead Man. Engineers kind of popped up in the mix lately. His and Her Grow. THC Wavy. I see you, baby.
Yeah, shout out Wavy.
I see THC Wavy. He's taking a lot of cobs and sticking them on heat sinks. Follow THC Wavy on Instagram. Follow Dirtman
Wavy,
Dan on
what's
Instagram.
Up, brother?
Grownonymous. I also want to point him out. He built a Canopy 10 light that, in my estimation, turned out cleaner than the one that I built. So shout out to Grownonymous. It's that reciprocal inspiration, baby. Right here, homie. All right. What else is going on? Oh, Hankel89, Tony Baloney, Fada Mike in the house, Craig and Rock. Real thing for you, Berkey, or a grown bud man.
Okay, ready for a couple more questions?
Sure, we'll take a few more.
Had a good one. Okay, where's this good one? Okay, so Stockton Slaps, I think that's what his name is, wants to ask.
Diaz brothers.
Cheap Roladro, is that how you say it? Cheap Roladro Cobs. Are they any good? He's building a 400 watts fixture that pulls 200 from the wall.
Okay. Roladro or Roladro. Yeah, I'm familiar with it. And this hits up on a great topic. That's actually an excellent question that I've been wanting to address. And I'll probably have to address it 10 more times. A lot of times what these manufacturers are doing when they're saying they have cobs and they're selling you a cob fixture, they're using the terminology very, very loosely. A cob is a chip on board LED that is one integrated circuit of a group of semiconductors that are all bound together to become one LED with one positive, one negative. This is done at the factory. Okay. What these multi-chip on boards, or they call them M cobs, are, all they are they're not a cob. Okay. I mean, technically, you know, if you put Lay's potato chips on a cutting board, that's a chip on board. You could call it a cob. But a multi-chip. You guys like that one?
That was a good one.
But
Let me
Sure
guess. This, by their estimation, by Roliadro's estimation, this is a cob. Okay, which it's not. It's a printed circuit board.
all chips on a board, bro.
Chips on a board. All they're doing is they're taking discrete chips and putting them very tightly on a PCB. That's why the back is metal, and that's why you see the little PCB lines connecting the electricity. It's not a cob. It's a very small printed circuit board with a lot of little LEDs in a tight package, so it looks like a cob. That's why they come out pink and stuff like that. So what I think you're going to realize with those Roliadros is that you're going to be somewhere around 1 micromole per joule in terms of your output, and that is lower than an HPS.
So you're not much better than the Blurples there.
Yeah, you're not much better than the Blurples. That's like lower than HPS. I would recommend you go over to Grower's House and get a ceramic metal halide for 315 watts and $299. It's less than $1 per watt, and you're up at 1.7 micromoles per joule, nearly 85% more output per watt in out of a CMH than a eBay Lite. And Bruce Bugby's study backs up that science.
NorCal Grower 530. He's asking what your opinion on Vipar Spectras are.
Same thing,
right? Well, one thing I can say about Vipar Spectras though. Yeah. Okay, so I mean specifically on these, and just comparing to what I've heard about other Blurples fixtures. I didn't have any diodes burn out on me. I used them for a while, a couple grows, and it's held up. I mean, the lights they're well made, but it's just like he was saying with everything else. It's the Blurple. You're gonna get about. I can tell you, I did a scrog in a 3x3. I'm sure I maximized my yield per my space and my lights. I got about a half pound, so that's kind of what you can expect from them.
How was the quality?
Yeah, they're well built. They're nice. Right? Oh yeah, fire quality. I mean, it's they grow the dank for sure, but the yield's just not there for me, at least. I mean, if you're new, fuck it, they're cheap, man.
Sure. Look, I'm not a snob. I understand everyone has to start somewhere, and believe it or not, even though I have all these components sitting around, just 2 short years ago, I was running on all HPS. The hoods are 10 years old. The ballasts were 5 years old. I couldn't really afford to buy Horticultural, so I bought iPower bulbs from Amazon for $30. One of them burnt out, and I had to start somewhere. I bought a Mars, and my budget at the time and the financial constraints I was dealing with at the time, it was just what I bought, So I'm not a snob. I'd rather you start somewhere. If that's where you need to start, go ahead, but go into it knowing that you're going to be pulling great quality. And quality is incredibly important, especially for your personal head stash. But you're going to be getting about $0.5 gram per watt. Most of the guys using ceramic metal halide and using chip-on boards are getting a minimum of 1 gram per watt with fire quality. So just know that going in. Just know, Yeah. But it's okay to get started, brother. Everybody's got to start somewhere. With it. Cool.
Is it okay? Reservoir Scroggs is asking, is it worth trying to save money on Cobs by using Vero or Citizen when the heat sink costs just as much as the Cob? So you're not saving a lot on the total build.
That's a good one. I'm tethered here. I'd go grab a larger heatsink. Fan-fucking-tastic question. This is a 120 millimeter heatsink, a little bit bigger than 4 inches. And it's capable of handling a maximum of about 63 watts or something like that. But really, about 45, 50 watts is kind of the sweet spot for a 120 millimeter. Then it goes up to 130. Then it goes up to 140. And that's all in the $15, $16 and under price category. when you start getting into this question, who asked this question again?
That was from Reservoir Scrogs.
Reservoir Scrogs. Been a supporter and a great commenter for a while. Shout out, buddy. When you get into running the Veros and the Citizens at these high currents, these high strengths like 2.1 amps or 2100 milliamps, you need a lot more metal than this 130 mils or 120 mils to support it. You need like 140, 160 mil. And then the freaking heatsink costs $25 for a chip that costs $25. So it's a valid concern. I don't know if I have any big answer for you there. The answer would be, in an economical build, you would not go with the pin heatsink because they're too expensive. You would go back to an extruded type of heatsink. And what that means is just a standard fin heatsink like this, right? And you would go over to like Heatsink USA, and you would get an extruded heatsink like this, and you put a fan over the top of it. Anytime you actively cool something, which means a dedicated fan running over the fins, you can run a smaller, cheaper, lighter heatsink with more wattage, for less money. Passive is expensive. Passive just relies on your fans that move your plants, your oscillating fans like Wookie has that do figure eights and backflips. So that's your answer. If you're trying to stay economical, consider going back to an extruded or even a CPU cooler design like High Guy Microbes has done. It's a $10 heatsink solution with a fan on top. Active cooling is the short answer to that question. Awesome question.
I got another easy one for you.
Okay, we'll do two more questions, then we're going to shut it down.
All right, this one's super easy. So if I'm going to start and I'm going to get that rapid LED kit, what are some tools that I would need to start out with? I know obviously a multimeter and some other things, but what are some things that you would recommend that you get first to start that build?
Well, the rapid LED kit requires only a small screwdriver and a pair of wire strippers, because it comes with these connectors here. And these are called Wago connectors. These are Wago 221. They're linked in the description of all my videos. There's also the Wago 222, which has evaded me and has evaded my desk space. It has fallen to the ground, but it looks somewhat similar. And what these are basically, they're like wire nuts, but instead of twisting two wires together, you insert them into this thing and clamp it down. And you can tie two wires together. You can tie 3 wires together. And there's also a 5-slotter that allows you to tie the wires together. So if you're going to use Wagos, you don't need a soldering iron. So, you can scrap that. But if you are, let's say SoCal, let's say you just get bit by the bug, like Loki or like THC Wavy, or like one of these guys that's like just building and building, you're probably going to want a good soldering iron and learn how to use it, because you might need it eventually, and some heat.
Yeah, I got a good one.
Okay. You need a good pair of wire strippers and a good pair of like small screwdriver sets, like eyeglass screwdrivers. And maybe a hacksaw or an angle grinder would be probably a good thing to have for cutting metal strips, because at some point you got to build a frame out of like angled aluminum or something like that. But with the kits from Cutter, Rapid, Timber, Cob kits, Northern growlights, they kind of set you up to where really you just need a wire stripper and a screwdriver and something to build your frame. Back in the day, we needed sets of drill bits. We needed taps for threading. We needed soldering irons. We needed a lot more tools than we actually need today. So just
Sweet.
the basics. Just the basics.
Sweet.
Cool. 1 or 2 more.
Sorry, I muted. Okay. So we got here. Okay, so EB, I think this was, I'm not going to ask this question because I saw somebody answer him in chat. I think Loki handled this question, so I'll skip that one. Shredder OG is asking, I'm going to make a full 4x8 of CXB. I have all the Cobs already, but half of them are on a Heatsink USA fin heat sinks.
Sorry. Okay. Sorry. Start over real quick.
Okay.
I feel like this is going to be a complicated one.
Full 4x8 of full CXBs. He has all the Cobs. But half of them are on a Heatsink USA fin heat sinks. How hard is it to remove the old CX beads, and will he damage them?
It's not hard to remove the old CXBs at all. If you've used a graphite pad and you've stuck that pad to the cob, it should stay on the cob for future transfer. If you've used paste as your thermal paste, you can just clean that off with alcohol. Rubbing alcohol will not affect the light emitting surface if you wipe it and dry it. So all you do is remove the chip on board LED from the heatsink, clean it with alcohol, and then you can move it over to your pin heatsink or whatever. It's removing it should not affect it in any way. Does that answer it, or?
I think so. Yeah. I think that's what he was asking. Just he was just worried about taking the cobs off and afraid he's gonna break them or something. So
No, you should be fine. It should be fine. Let's do one more, and then we'll go into some channel stuff.
Okay, so we got MC Green with the last question asking, Grow Mouse, will a cob run at any wattage? There are drivers with 1700 or 700 milliamps, 428 volts, and 299 watts of output. I'm not. He's saying that's 11 36 volt cobs, but only 27 watts each. Will that work?
1130. No. Your voltage on your cob. Okay. Without getting too complicated, this is a 36 volt cob, and that's a shorthand nomenclature as a label for this cob. Voltage is variable. So the lower you drive a chip on board LED, the less volts it uses. Think of voltage in a chip on board as like watts, almost like when you plug something into the wall, it uses that electricity, right? Like a space heater uses wattage. A chip on board is the same, works the same. When it's connected to a driver at a various current, it uses volts from the bank of the driver's volts. So if you're running at 700 milliamps, this 36 volt cob might only use 33 volts. The same cob might use all 36 volts if you're running it at like 2.1 amps. So you can fudge things a little bit. Like let's say you did a calculation on a driver that said it would run 4.9 cobs that are 36 volt. Okay. And you're like 4.9. I wonder if I could squeak out that fifth. If the current on the driver's low enough, like a 700 or 1000 milliamp, it'll shave a couple volts off of what this thing needs to turn on, and you can actually fit that fifth cob. But if it's a higher current driver, like a 2400 or 2100, you better calculate that you're going to need all 36. 36 volts in shorthand is the minimum needed to make this thing make light. Without it, it just doesn't work, doesn't turn on. So threshold. I think that answers it.
Yeah, I think so.
Okay. Well, very cool. Very cool. Well, that's going to kind of end the question and answer portion. I want to give both SoCal and Wookie a chance to kind of pimp their gardens and stuff like that. So SoCal, tell us a little bit about your channel.
Well, my channel is, you can learn a little bit from there. I try not to, spout out too much bro science, but just so everybody knows what we do here on my channel, that what I do talk about is things that I know, as far as I know it. So anytime you want to leave a comment down, correcting me or helping me out, I'm in full learn mode for the rest of my life. So, and also my last video I put out, I've been working a lot this week. It's not an excuse, but I'm kind of tired of my videos. Me and Wookie were talking about it. We both want to, elevate our editing and stuff. So, keep an eye out for better videos coming up, just a little bit more put into it. I got my, more time coming. I'm not going to be working as much. So there's definitely some better things coming in my garden, just, one thing at a time. So
looks like you're growing some TGA gear, some jelly beans, some hammer, 9-pound hammer. And
yep, I've been growing some TGA for a long time. I've always been like that, and it's going to sound weird, that fruity guy.
I love fruit.
I'm a fruity guy. Yeah, so, and I've always been waiting for that OG infused fruit, and if, Vader and Sub end up doing something one day, that'd be pretty tight. That'd be cool.
Well, I think all of us just, yeah, go ahead.
You got some ocean grown gear coming, don't you, SoCal?
I do. I got some ocean grown coming. I got some Obi-Wan Kush, and I got some of I'm on a waiting list for the Jedi OG. So
Oh, very cool. Very cool.
Can't wait for that to come in.
I'm just trying to work out the space to pop my Jedi as well.
Oh,
So
sweet.
that's great, man. It's great to have you back on YouTube, and definitely
Good to be
great to
back.
make your acquaintance. And thanks for coming on this morning.
Thanks for the invite, brother. I really appreciate everything.
Cool. And Mr.
Oh, don't
Wookie
forget to
Kush.
pimp out your. Hang on, bro. Don't forget to pimp out your giveaway, bro.
Yeah, I got a giveaway. A lot of people are asking if it's still going on. The giveaway is going to be going on till like mid next month. I didn't realize that I have so many subscribers left to go. I think there's like, maybe 200, and I'm not sure if we're going to hit that 200, that 5,000 subscriber mark by the time the giveaway is over. So if it ends up being up before I hit 5,000, we're just going to keep it at that. And but hopefully with a little bit of push, I'll be able to get to 5K before the actual giveaway. And but if we're a little short, I'm still going to do the giveaway. But yeah,
Let's
you can
brag
get
these folks, because you're sitting at just 4,700. So if we could get 300 people to subscribe to you, SoCal's Cannabis Garden here, SoCal !S Cannabis Garden. I mean, we're talking about giving away a seed sprout kit, an LED, and some cool shit, right?
Right. Yeah. Right. Yeah.
Do it. Do it.
Do it. I mean, within the last 30 days, I think when I looked at my analytics, I've gotten about 300 subs. So it's definitely doable.
We can
Once
do
you hit the
this.
5K mark, bro, it starts getting a little more exponential. It gets a lot more fun, a lot faster.
Yeah, I can't wait. That's for sure.
Mr. Wookie Kush staring at the bottom end of 1,000 subs pretty soon. He's at 779 coming up in the game. I think I remember you having about 250 here a little while back when I first
A
looked.
couple weeks ago, yeah. Just a couple weeks
Oh,
ago.
wait.
It's kind of been rolling in the last couple weeks.
Wait, you had 230 or 250 when you first started helping me produce, right?
Yeah, I think it was 350, but yeah.
Oh, it was
Yeah,
350. Okay, damn.
Yeah,
so
but
you
it's been. I mean, it's just been rolling. Yeah.
doubled. So, man, how good will that feel to hit 1,000 subs, man? Triple digits.
It'll be good, man. I think it'll feel good. We're gonna do a giveaway for sure. I got a couple things I've been putting together. I don't want to give anything away, but you can expect some cool products. You can expect maybe some beans. We'll see what happens.
Ooh,
Sweet.
some beans. You got me interested. Okay.
Yeah.
Well, can I enter?
Yeah.
So Wookie
Yeah,
Kush is following along. It's a new hope. We discussed this, but he had a little bit of a collapse on a hydro stand. He's beefed up. He's reconfigured his room. He's out of the tent. He's running a 4x4 with ocean-grown dark plasma under 16 Citizen CLU 048. So you want to talk about CRI. He's running a mixture of 80 and 90 CRI. So you're sitting at 85 CRI. So, yeah, dude. I mean, I'm watching. Obviously, you see the little red bar means I've watched your video. So, yeah.
It's been going great, man. I mean, I can tell you the plants are responding really well to the lights. We're kind of getting up, coming up on where we were, so it'd be nice to be able to compare. We kind of saw where we got with the blurples at day 23. See that nice shot of that little budlet starting to form right there. So it'd be a nice little comparison. Saying for people looking to compare on how far it'll go with with the Cobs at that point. So we're almost back to where we were.
Well, since we're in the last few minutes, the stream's ending in 2 minutes, but for everyone that is still here, oh God, Green Gene. I said, how good would it be to triple digits? Yes, quad digits. You're right. 1, 0. See, that's just me, guys. Simple math. Micromoles? Sure, let's do that. Quad. Okay. I guess you know what? This is green. This is the Green Gene payback. I gave him so much shit last night, and he couldn't even defend himself about Tech Talk. So yeah, we'll get a syllabus put together for a Tech Talk. That'll probably be just me and Green Gene doing that one. We might have a producer helping, and then nothing guaranteed, guys. Do not go mark this on your calendar. In fact, write this. Don't even write it down in pencil. Write it in dry erase so that you can just smush it away. But there might be a very special live stream with a very special guest tomorrow, Sunday, March 19th. Probably early for you West Coast guys. And it'll only be 20 or 30-minute stream, but it could possibly be covering some technology that I don't know. My computer chair is still kind of wet over this. It's not wet. It's solidly moist. It's solidly moist down under here. So
There's no filter in that helmet, is there?
no, well, there is, but it kind of makes more stupid shit come out. You
Oh,
put the
that's
helmet
funny,
on, and I would never say this without it, but
That's too funny.
no, don't get your pencil or your pen, dry erase marker. Just, when you're up tomorrow morning having your morning coffee, maybe check in, see what's going on the tube, see if there's anything, kind of exciting going on. So there we go. Okay. Well, channels have been pimped. LED knowledge
Appreciate
has
it
been
very
dropped.
much.
I appreciate you guys. Thank you for joining me, Grow Mouse, Wookie Kush, and SoCal's Cannabis Garden for another Saturday morning LED stream. I'm not ready to commit yet, but if it goes down on Saturdays. Thanks for watching, guys. I'll see you next time.